Hey Ricardo. Hey everyone.
Hey Josh, everyone.
How you going?
Good. Hello, note taker.
No responses yet, I guess. That's the next feature.
I know, yeah. The AI is gonna reply with some Ghibli images.
Maybe happy greeting back.
Exactly. Let's see if
Hey,
Ron shows up. I don't know if oh yeah, there's Ron.
Ricardo, you in London next week or
Yeah,
Good morning.
yeah, I'm actually in London, so I'll be arriving on Sunday and leaving on Saturday the following week. So I'll be there the whole week.
get to see you in person then?
Yeah. Yeah, we should catch up. Uh,
Absolutely.
Unfortunately, Ron is not gonna be able to make it, but I think he might make it to Atlanta or
We
something
shall
else.
see.
Yeah.
I used to live in Atlanta, so maybe that'll give me more motivation.
Yeah.
All right. Ricardo, you want to do it or you want me to?
Up to you. What do you feel like?
Um, huh?
What do you feel like?
All right. I'll get it going.
Okay.
Hi everybody. Good morning. Sorry I was a minute late here. I was actually stuck in the rain. I didn't know it was actually raining until I went out of my house. Got rained on. Um, so welcome. It is March 28th, 8:03, and we are starting our twice monthly meeting. Today we've got two members, but we'll call them guests because it sounds more like luminaries. We have Josh and Emily who will be presenting today. We'll talk about that in just a moment. So the agenda is typical game plan, talk about upcoming events. Uh, we'll go through kind of standing items. We have a great update from our own Deep Patel. And after that, we'll get into our presentations, and any time left, which I don't suspect we will, we'll have Q&A. All right. So make sure I see most people are here, but in case they're not, where is the chat? It's on the other window. Oh, thank you, Ricardo. You read my mind. All right. All right, upcoming events. Looks like we've got KubeCon. Is this still true? I wouldn't know. I'm not going. Anyone have anything to report on? Anyone speaking? Not this time. All right.
Yeah, I have a
Well,
few sessions.
oh, you do.
Some of them related to, or I think pretty much a lot of them are going to be related to the tag reboot, the different structure that the CNCF is creating for the technical groups. I think this working group might get affected a little bit in terms of like where like the reporting structure is. It sounds like this group might end up being working directly with the technical oversight committee. But I don't want to get myself ahead, and we'll let that trickle in after KubeCon because there will be some announcements after KubeCon.
All right. Good luck with your talks.
Yeah,
This
Good
and
luck to the TLC.
sorry.
this won't be an official talk, but Docker is doing sort of an offsite event, and we'll be talking about some of this. We'll be available to answer questions about some of the stuff I'm going to be talking about here. I can send folks the link if anyone's interested.
Yeah,
Sure.
please share. That's great, Emily. Excellent. You
Yeah, I
just
can share.
reminded me, Emily, as well. Cameron, who is not here, last I heard, is either running one of the unconference events that are happening across the street. So we should probably ping Cameron as well to make sure we know what's going on.
Yeah, so the other thing that I wanted to share is that I pasted on the Slack channel as a blog or doc that I wrote pre-KubeCon about this working group. So feel free to share on social media or with whoever you think might be good to share with.
There in the notes. Ricardo, are you here in the notes? Or am I even on the right day? No, of course I'm not even on the right day. Who started putting the second thinking here? This is very confusing. All right. Let's go. All right, so that's KubeCon. Safe travels to everybody. Hopefully you have a good time. I think before our next meeting, is this actually true? When will that be? Right near the same our next meeting. There's the AI user conference here in San Francisco. So I believe there's still a free tier ticket. So it's Tuesday, Wednesday, Thursday, Friday, or Tuesday, Wednesday, Thursday. It's at Fort Mason. I'll be there. Other than the morning of the first day, I'll be there the whole time, working the Association for Community Machineries chapter's booth. But I will be there the whole time. So if anybody happens to be around, even if you don't go to the conference, you want to just grab coffee over at the interval or Rat House, please shoot us a message. Some of us will be there. Okay, I think that's it for the near term conferences. Right. Standing issues. Okay. Think we recognize everyone here, so maybe we'll continue on. All right, we're not going to go through all those outstanding projects because we don't have much time. Deep Patel, care to talk about the latest news on the security white paper?
Hey folks, so good morning. So we have just come up with our first draft ready for review. You can start taking a look, provide comments, and those who contributed, Josh is here. Thank you very much for stepping up. So yeah, I think this is a first draft, I would say, because there are some small changes we may have to do, and anyway, we have to work on comment, but this is otherwise from content perspective ready.
Very short and sweet. Thanks to Deep. Deep has done the lion's share of work here. You know, these papers have a life outside of their own, and very often that life transcends many people. So, but Deep commanded and controlled this one. So thank you very much, Deep. But as Deep mentioned, we're not done. I think the best thing for anyone here, if you want to contribute on this, is just read the paper. It's a fairly long one. It's like 45 pages or whatever.
60.
60. Oh yeah, now the graphics are there.
Yeah.
So and that's not a bad or a good thing. It's just a thing. So it takes a little bit of time, but we really need to make sure it reads well, right? It's hard not to dedupe things or to dedupe too much. If there's any conceptual things, of course, that are wrong, we don't obviously want that. So even if you can't read the whole thing, maybe just pick a section and noodle over it. And that includes the sections that you may not even know about, right? We want this paper to be useful by people who don't know these things, right? So if you can read a section you may not know much about that actually would be great. And then just drop comments in there, and we'll try to finagle it into round two here. But we do want to see this one done. All these papers, they're never done. There's always room for version 2 because things change. There's always room for additional blogs. So if that's how you'd like to participate with this kind of thing, please do. Okay. Thanks again, Deep, and let me know when Tag Security gets it and they let us know what they think.
Yes, I'm about to send it to them as well.
Okay, great. Awesome. All right. To keep this train moving, Josh, are you ready? If you are,
I'm ready to rumble. So whenever,
awesome.
let me.
Yeah. So everyone, Josh, our own local member, now guest from Cisco, will be talking about communication flows and their impact on agent architectures. This is clearly in the realm of one of the hotter areas of AI right now. So this seems very pertinent to what we're doing around here. So without further ado, Josh, take it away. I'll stop sharing.
Perfect. Thank you, Ron. So let me go ahead and share my screen. I've got a bunch of displays, so let me know if I'm actually sharing the right screen, if you're seeing the big one or the small one.
I see a bank account. No, there's a presentation. Interactive conversation, agent traffic patterns.
Okay. All right. So thanks for having me on. A little bit of background around this session. So my hope is that it's interactive. It is a new field. In terms of AI, agents is up and coming, where the dust is certainly not settled in terms of where we're headed, where we're going to, the security risks, the challenges. So there's no such thing as a stupid question, just stupid answers, and that's probably going to come from me. So the hope is that we can talk together and share different perspectives around this, and hope the session's useful. So for those of you who don't know who I am, so my name's Josh Alley. I'm a principal architect at Cisco in the CTO office. Key areas that I focus on are AI ops and cloud native. I'm currently working in a team that are building AI agents for numerous different things, mostly in the area of AI ops. Aside from my standard work, I'm an author for Pearson, working on my second book at the moment, actually. Have to submit a bunch of patents and defensive publications within Cisco. And obviously, I'm a big fan of open source and open source community. If you're wondering where my accent's from, I'm an Aussie, although my accent's sort of washed down by now, and currently based in Munich. I don't have any logos from my company in here because I'm not advocating for any technology. The opinion, maybe I'm aiming not to say anything disparaging about anything, but yeah, the opinions are my own. So if I say anything about technology, don't assume that it's roadmap and it's going to be released in any of our portfolio. So just sort of a primer here in terms of networking. So if we look at networking today, we have source and destination IP addresses. You'll have one system which is communicating on one side of a network, and it's basically sending traffic to another side of the network. And the traffic patterns that you have within a network tend to be based in the most simple terms using what we call routing protocols and metrics. So in this scenario, we can see that the lower path in the fish, and the fish is there just so people remember things, the lower part of the fish has an extra hop, a longer metric, which makes it usually a worse path. That's the general way that networking works and how forwarding paths works. In terms of how we are handling forwarding today, communications tend to be human to human or human to system. Now, this is an important part, which we're going to get to a little bit later on, that today, if there's a critical activity being performed, I'm a human operator working on a system connected to an IP address, which is a crane, and something goes wrong, I can call the supervisor. We're going to be looking at how that situation may change in the context of agents from where we are today, where there's a human which is heavily in control and has the reasoning capabilities to understand good, bad, and the ugly, to where we're maybe going to end up in a more nuanced situation world. So where do we see potential for agent architectures. So essentially, Kubernetes is a fantastic carrier. Containers are a fantastic carrier for agent architectures and technology. We're seeing opportunity for agents cooling in the public cloud and data centers. Private cloud architectures, we're seeing agents being deployed in Raspberry Pi type architectures down to industrial systems, manufacturing, defense. We're really seeing the pervasiveness of agents essentially becoming a replacement for various functions, code, containers, and so forth, all across the board. And as time moves forward, we're really going to see a much broader usage and replacement of agent technologies, really all across the internet. So we're really looking at that end-to-end, system-to-system, organization to organization, agent to agent, humanless communication in many cases, which makes it an exciting time at the moment. Now, coming back to the first picture which I had, which was the fish. So at the moment, in the past, we had human-to-human communications, which is pretty straightforward. You know if you're actually receiving the message so you can respond to it. When we start shifting to communication patterns between agent to agents, then we've got other things to start worrying about. Can the agent actually reason if a good or bad thing's actually happening? If there's an emergency, can the agent actually signal the right action back to a central point? Do we have continuity over the responses coming from the agents in terms of their ability to actually provide us with a standardized and regular response? And in terms of an attempted action, will it be repeated in the case that the traffic, and this is why I'm showing the network here, in the case that the traffic doesn't reach its destination? Will it continue to retry, or will it try one time to perform a critical task that may have a consequence of sending out shipping manifests, sending trucks to destinations, scheduling boats to leave their ports? If that communication doesn't go through from these pseudo-intelligent systems, what are the respective repercussions, and how can you monitor and ensure continuity in terms of the actions that agents are taking when they're traversing over the network? So these are all questions which in the future, I guess, we're going to be solving. So when we're looking at the communication matrices, we're seeing, and I'm using IP version 6 here. If you're looking at the addresses thinking, why is this not just 10 dot something? It's a lot easier. I'm listing IP version 6 because what we tend to see, at least in Europe, is we're getting a lot of legislation coming in with the EU AI Act, where we need a means to provide explainability around agent architectures and AI. What's happening? How did the system communicate with the other system? And how did the reasoning path perform to come up with a conclusion for execution? Now, if we look at the IP version 4 addressing, most of the time we'll receive a private address, a 10 dot something address, or 192, and then it's translated to an elastic IP address, and then basically the source information is heavily obscured. With version 6, we have the ability, essentially we've got, I don't want to say limitless addressing, but there are a lot more addresses available to be consumed. And through that, there's a higher capability to really determine what the source and what the destination may be, and feed that information in from an explainability perspective that provides a more coherent end-to-end view of which system performed which action at what time that resulted in a potential positive or negative outcome, right? So looking at how the communications may happen, we've got, in this scenario, multiple clouds, multiple devices. Some devices are consumer devices, other devices could potentially be critical systems that are related to transport or defense. Now, you can see I put a whole bunch of Kubernetes logos here and container type logos on here. So the form factor, I think if we're looking at the industry at the moment, we're standardizing around containers for the deployment of agents. In terms of the communication protocols which are used between the agents and the tool sets which are being used, We're seeing at the moment a heavy tendency towards MCP for agent to server or agent client to agent server communications. And we're also seeing various implementations from various different organizations for agent to ACP communication, so agent communication protocols between agents themselves. Now, the protocols themselves are the one thing, but if we're looking at this picture, if we consider we've got cloud provider A and cloud provider B and all these different services which may belong to different entities, then we start talking about things like federation. Who owns this resource? I've got an agent that belongs to Acme Corp that needs to communicate with XYZ Corp. How do we build that communication? And how is that communication built in a trusted, identified, and secure manner? So these are some of the challenges which we're currently seeing in this space. Within an organization, sure, we can have systems, microservices communicate with one another without too much problem. We expose the ports and everything's sort of up and running. But when we start looking at the communication matrices that may in the future exist, potentially when we're looking at millions of agents communicating with millions of other agents over the internet in private or public networks, or in both at the same time, then we're represented with a problem space that is a little bit different to what we have today, given the autonomy and given the fact that the systems may not necessarily always have a human operator in the loop. So taking a step back and looking at Kubernetes or cloud native again, we have different ways at which we handle our communications. So within a pod, if we have multiple containers, we're using a shared network namespace and essentially exposing different ports. When we're looking pod to pod, we can communicate over the pod CIDR range via service mappings, or under circumstance using service mesh. There's numerous service meshes, Linkerd, Istio, and Cilium, plus others out there too, right? Cluster to cluster communications when we're looking from a Kubernetes perspective, and this can work depending on the solution you choose between K3 and K8. We also have the potential to use service mesh. But generally, service mesh association between clusters requires common certificates to be exchanged. That means when you start looking at that scenario of Acme Corp speaking to XYZ Corp, potentially you're going to run into a challenge. And the identity component and the security components with building a service mesh between different disparate companies or organizations in itself can represent a challenge. So looking at other forms of communications. So we've got various traditional routes to actually provide communications from A to B. The first one is a firewall and then no security downstream to your respective systems or agents that may be existing in the public internet. Other options are using overlay technologies such as VPNs or Geneve or VXLAN, some of which are also serviced through service mesh, but tunneling itself is potentially an option. Now, the one on the right-hand side, many of you probably are not familiar with it. It's heavily in the service provider space, and this is called segment routing or MPLS, and this technology tends to be leveraged to provide what's called path affinity in traffic engineering, which is a fixed path through the internet or through a network to ensure that you're getting the guaranteed bandwidth which you may require and potentially avoiding certain countries where traffic should not go. So let's say I know that one country may want to steal my technology. I can pin a path through the internet that avoids that country so my traffic can never be tapped within that country. So that's sort of the thing that SRv6 and MPLS and traffic engineering can achieve. Under circumstance and agent technologies, if you have a super mission critical agent type architecture, and this actually isn't limited to agents, it's any traffic flow for this matter, you can link that architecture in with an SRv6 traffic protection policy, which will ensure your traffic does get from A to B without being dropped. Or what we've actually seen also is on back-end data center fabrics, which are used for training, we have seen SRv6 being used to ensure that there's no out-of-sequence packets that could affect your RDMA Rocky version 2 communication. So We're sort of seeing it in two spaces there at the moment. So the next thing that we're looking at is, in terms of the agent-to-agent communications, you've got the IP networks, which are essentially your transit for your plumbing or transit for the traffic. There's also the whole topic of how do we actually register an agent? How do we map an agent from A to B? For this, there's also no silver bullet, right? And that's why I'm sort of pointing to this interactive conversation. DNS is one idea which is being sort of passed around between different organizations and teams and people who are influencing direction here. And the TXT field, which has been existing in DNS for a long time, has been used in many cases to add extra metadata into your DNS records to be able to provide something meaningful, right? So you can add a key identifier, an agent name, a service, something like this. So this is one school of thought that DNS could potentially be a decent registry for agents. Another one is using multicast. Now, multicast provides an ability to essentially lower your overhead in your application stack. Because under circumstance today, when you're spinning up and sending more traffic, you're going to have to horizontally scale to handle the number of ports, network traffic that's happening between systems. Multicast allows you to lower your application stack overhead by essentially allowing one stream to be sent to many, many systems, select systems that subscribe to it in parallel. This is also a sort of domain that's being seen in the context of, could this be a decent technology for agents? Because with multicast, you can subscribe as an agent client to a particular stream, which gives us updates or information which is relevant at a particular time. Now, maybe traffic's not an issue in the normal internet, but when we start looking at low power and lossy sensors, where agents are also installed, IoT devices, potentially even ambient intelligent devices, where on your clothes, you may have an IP device that only turns on once per day at 6 o'clock to get updated with information. These sorts of devices do need to sort of work in a different way of operation where they're using as little IP packets and power and energy as possible. So in this space, nothing's decided. Every week there's another community basically issuing a different direction and what the best thing would be. I think, just like anything, VHS and beta, we're going to come to a decision at some point in time. But really, there's a lot going on here at the moment. So the key takeaways, arguably, agents fit perfectly within the containerized cloud-native architecture and ecosystem. Agent-to-agent communications, at this point in time, there is progress, but I think it'll take a while until we hit a point where the dust settles and everyone says, hey, this is 100% the direction we need to go, and this meets all of our key requirements. There are some solutions with agent to server, which are under the banner of MCP, which Anthropic brought in November last year, or open source November last year. However, MCP itself is great for agent to server communications, but it doesn't solve the problem with agent-to-agent communications. And for certain scenarios, you want your agents to be able to communicate directly with one another. Federation, identity, security, and explainability, we're not quite there yet. It's still a lot of work in progress, but these are interesting domains for all of us, I think, because eventually we will get to a point where me at Acme Corp will be able to subscribe to an agent flow or activity in corporation XYZ and really benefit and get gains from it. In terms of network communications, there's all different methods there. I'd say the most cloud-native one is service mesh. But again, today, service mesh is not augmented by that federation identity security component, which could lead to it being able to be used in a more involved manner between organizations. So that's basically my 5 cents. Happy to hear input from the team and open it up for discussion. I hope it was an interesting lightning talk or pitch.
Gosh, thanks. That was actually very well done. Very, very nice. I'll give you the round of applause. I do have a question. I'd like to get your thought on something. So some of these technologies and I know you weren't going to talk about work, but you probably have a better view from that side of the fence than I do. Do you think things like agent-to-agent protocols are going to manifest from the ground up, or do you think it's going to be more of a top-down, the big companies, the professional societies, right? IETF or whatever, are they going to drive that conversation? Because with the model context protocol, one company kind of dumped that on people, and it seems to be catching fire, at least for now. But like you said, that's not the whole picture. So how do you think this game's going to play out?
So my personal view is, if you're looking at a lot of the research work that comes out of universities, every other month there's a framework that was better than the last one. And, you're seeing like an amazing amount of innovation there. I think my personal view is that we haven't hit a point where the dust has settled yet by a long shot. I think as long as the innovation continues to prove viable, I think we should keep an open mind. I think MCP is an option today. Is it going to be an option still in 6 months? Is there not going to be an MCP 2 or something better? It's difficult to say. If we're looking at the best practices of microservice design, you're looking at essentially the concepts of information hiding within your service, right? So you're only exposing the complexity and mess of your service outside with the ports that actually need to be exposed. Arguably, if we want to look towards standards, MCP seems to be gearing in that direction. But if we're looking at what's been standard for many years in those architectures, you're looking at things like gRPC, you're looking at HTTP over or REST over HTTP2, potentially REST, which is a bit more obscure, over HTTP3, right? So you've got these sorts of things being exposed, and really, which protocol will be the best one in the future to model and set up your agent-to-agent communications? My personal view is play it safe and expose everything. So then later on, when somebody decides, I think it makes sense to stick with gRPC or HTTP over REST or MCP, then it makes it easier. So that would be my suggestion. Keep your framework, keep your design set up in a modular enough way that you can basically. Sorry, go ahead, Ricardo.
Oh yeah, question is, do you actually see? It's kind of interesting that you actually see AI itself being used in managing protocols or managing communications between agents to improve throughput, latency, and efficiencies, right?
So we're sort of seeing this already today in the context of predictive maintenance and trending. So the service providers have been doing trending on, essentially trying to smell the smoke before the fire in many cases in terms of the durability of a circuit, or, when is a component going to fail, or how is the latency on this link or the other link. So you've got more narrowband models, not necessarily generative, that have been geared towards that sort of thing for a very long time. In terms of agents self-healing or identifying their own situation, I can imagine scenarios where maybe you're going with a narrowband AI solution that would couple in a sidecar or couple in the same pod to do the sanity check on the generative entity, which is just, difficult to control. I certainly see a use case for that. It's just a question of what side of the connection are you looking at it from? Because when you're sending communications over the network, it's Rx to TX. And it can be that your transmission path from A to B is super robust. Everything's working 100%, no packet loss, everything's fine. But the return packet is impeded. So if you've only got the view from the one side of that agent, how will it actually know? Was it the path towards the resource that was problematic, or the path back? So, this obviously can be solved with communications between multiple systems, but yeah, I can see that there's value in that in some form of self-sanity checking and assessment.
Makes sense.
Also from a communication path.
Yeah, and it sounds like it's more on the predictive side, right? It's not so much on the generative, because I guess generative is, I mean, you can't tell what kinds of responses you're going to get, right, from a generative agentic system. But I think it could also be used as a way to suggest type things or maybe to troubleshoot, right? So yes.
Like if we look at generative, the CIA, for instance, they're using 160 generative models, which are basically reasoning separately to come up with a standard answer, right? So they're not trusting in one particular source of truth. They're not trusting in one generative model being the one which decides on what it is. They've sort of hedged their bets on many different generative models in parallel, and then I guess if 80% confidence from all of them, then maybe it's a green line. So
yeah, I mean, there are a lot of conversations about using LLMs as a judge, right? So so that's something that could actually become a thing. I mean, but yet to be determined.
Indeed.
Just one question, the very basic one. So fundamentally speaking, if you take basically agent to agent communication, assume that it is going through a networking or some kind of fabric, on a very coarse level. And there are plenty of applications out there with both the scalability requirement and the latency requirement. Why so much noise in this case otherwise? What is fundamentally speaking, we are talking about additional protocols, additional, latency issues, I think, but because there are plenty of aggressive applications for latency needs and actually scalability. So what is so unique here?
I guess that the difference is your communications are under circumstance in natural language, right? So it's not like you're building an application where you've got a fixed function and routine that runs, and if this doesn't happen, then you land in fail or closure or repeat, right? So you've got some frameworks which are more programmatic, like DSPy, that is more programmatic than some of the other agent frameworks which are out there. But really having the continuity in the execution of routines for critical things, it differs a little bit, right? You're not always going to get the same answer. You're not always going to get the same conclusion if you're dealing with LLMs. And I guess if you lose your communication between two systems, what's the agent going to do? Is it going to bug out and just go in loops, or is it actually going to, we've seen some funky stuff with agents that get confused. So, does that disruption in the communication path lead to a point where the agent starts spinning? That would be my conclusion here, Deep.
So is it just an attempt to bring some, let's say, some kind of protocol sitting between the agent and the networking fabric to solve problems of agents missing the server or something? I mean, the one example is that when the video protocol came way back, there came RTP, RTCP because something at the application level needed to take a quick decision and move on actually quickly. Is it that kind of attempt?
So I think socket programming and bringing in this sort of thing, this works when you've got fixed functions that you're programming, right? Like the concern isn't will the socket reestablish, the concern is more around if that agent is on a particular trajectory and path in its reasoning and gets broken in between, how will it recover?
And how fast, I guess, right?
Maybe it's fine. Maybe it's a matter of building the right chain of thought for it to execute in the right way, but maybe it's not, right? So I know we have another session, so I don't want to steal anybody's thunder here. So
Good stuff. Justin, that was great. And you'll share the slides.
absolutely. We'll do.
Awesome. Well done. And thank you for that. Great time before KubeCon.
Sure
All right.
thing. Thanks for having me on.
Yeah. All right. Our next speaker, patiently waiting, Emily Casey from Docker, will be discussing specifications around OCI related artifacts in AI. So Emily, thanks for being here and take it away.
Hi, everybody. Get my Zoom things all in the right place. I'm Emily Casey. I'm a staff engineer at Docker, and I'm here today. I'm going to be mentioning some products that Docker is launching, including a new like Docker model runner and sort of the motivation behind that. But the reason I'm here is not to pitch Docker products. It's to talk about how sort of some of the problems we're solving in order to launch these products at the core are common problems that exist across a bunch of tooling. And it is in, we believe, in the best interest of the community for everybody, you know, that's each solving this similar problem in a slightly different way to talk about it more and come together and work on something more standardized. So this is gonna be my disclaimer is also this is like very early days stuff. I'm gonna be showing you some things like a repo we're gonna open source, you know, before Monday, but it's not open source yet. This is all very in progress, and it's more of an informal discussion than a presentation. So feel free to interrupt me as I go and ask any questions. So the way Docker has been thinking about the experience for AI engineers is there's a whole group of engineers out there that are already familiar with containers, familiar with the cloud native ecosystem, and they're starting to interact with AI and large language models for the first time. And this can be a big learning curve. It can be a little bit overwhelming. And we want to help create a developer experience for them that feels familiar. So instead of having to learn about a bunch of new tools and interact with new registries, we want people to be able to use Docker and, you know, pull and push models from Docker Hub or their private on-prem registry or the tooling that they're already familiar with. So take this unfamiliar world that they're having to learn about so they can build their new applications that integrate with AI and make it feel as approachable as possible. Because one thing we've seen is that people want this workflow, but just naively running an LLM in a container in Docker Desktop and a Mac or something like that has some serious performance problems in terms of you don't have access, you know, to the host GPU. The way the artifacts are formatted, these very large high entropy files are compressed and archived, and you're wasting a lot of time uncompressing, unarchiving them. So we see people want this workflow. It's like just run this in a Docker container, but it's not delivering the right performance when you do that without, you know, changes and help. And that's why we're creating this Docker model runner product that in the beginning is focused on running LLMs locally in Docker Desktop. We're going to be open sourcing the core components of this. And then on the roadmap, I mean, whatever legal disclaimer, I can't like promise anything, but it's on the roadmap to put the stuff in Docker CE and then like work on a story that integrates like all the way through the cloud native ecosystem to make these things compatible. So, in service of that, we have been working on a specification for packaging large language models as OCI artifacts, but not necessarily as container images. The way we've been approaching this is first like solving the problems that we need to solve to create a great experience in Docker Model Runner. But now that we've solved those, we want to try to work with folks to, you know, figure out who's solving similar problems and try to evolve this into a standard if that's at all possible. So the goals that we've been solving for Docker Model Runner is we want people, we think it's very important for OCI registries to be the distribution mechanism, because everybody has already solved the problem of getting a registry that they believe is compliant with their security requirements and, you know, has their organization mapped. So to the extent that we can piggyback on this existing technology, it's obviously the right thing to do. But we do not want to distribute these models as container images because we would like to distribute the model files themselves, like the model weights, unencrypted and uncompressed, so that you're not wasting time unpacking these large files when you're pulling them. And we also would like to provide a standardized metadata format so that registries, before people pull these models, can surface the information people need to know which model they want to pull. And then maybe take that a step further so that tooling, can inspect this metadata, because there's new problems running LLMs locally that are different than deciding which variant of a container to run locally. Like, you don't just need to know what your operating system is or what your architecture is. There will be different sized variants of these models, and you want to know what resources you have available in your runtime and pull the right model for that. So you need to surface that metadata in a way that can allow users to make that decision and also allow tools to make that decision for users based on what they can determine about the environment. So as these are the problems that we feel like we needed to solve to create artifacts that work well in the Docker model runner. We also want to make this an open format so that anyone can publish compatible models. And any OCI registry can surface this metadata. So that's like, there's a lot of motivation to try to open source and specify this format even just to support Docker model runner. But obviously that's just one tool. And the right thing for users is to sort of create an ecosystem where things are interoperable. So our goal is to take this starting point and, try to get in contact with everybody who has a variant of this. We know some people solving similar problem out there already. I'm sure there's even more that we don't know about, and try to see if we can converge on something that meets the needs of all of these runtimes. And philosophically, we want to create an ecosystem where models are first-class citizens. It's not just a flavor of container, and that requires everybody to get on board with a common definition of a model and model distribution so that we can build out this ecosystem where everything just works for people. So that's sort of like the pitch for why we're doing this. I will give you guys the link to this specification repo, and we can quickly look at some of the types of things we're trying to do. Like, we're defining, instead of providing layers that are layer diffs in the container file system diff as specified in the image specification, all of our layers are not layers. They're just plain files where the media type gives you the purpose of the file. So far this is pretty minimal, but we're specifying media types for a model, packaged as a GGUF-v3 file, the same thing, but a LoRa adapter in that file, and, licenses, so you can distribute things in a compliant way. And we're working on specifying how you can surface the metadata that that the registry needs and the user needs to understand what they're pulling and make the right decisions. So you can see an example of something that we have in Hub here, a Gemma 3 model. I said this was early days. You can see that the manifest matches this format with the new media types. But the config is still evolving from an older version. So we're really, we're in the process of figuring this out. And we will be open sourcing. This is private, but I'm comfortable sharing it. It can be open source today, maybe, if not, this weekend. Tooling for creating and managing these artifacts. And we will eventually be open sourcing more of the model runner core itself as well. So the reason I wanted to come here and talk about this today is just to like raise awareness that I think there is this big gap in the community where we need to work together to find a standard here so that the ecosystem can grow. Yes, Ronald.
First, thanks. This is I love this kind of stuff. Thank you, Emily. I do have a quick question. The management, I can already kind of envision where you're going with this, and that seems my gut reaction feels positive. But I do have a question around the hardware. Is there anything here? Like if I like in with current stuff, if I download it for the wrong architecture, it's not going to run. Here, what would be very useful is like I'm on this computer and I have this kind of GPU. So would that be something maybe there that would be considered like, if I'm using this in a cluster, same kind of thing, like I would report back that I'm in an environment where I can't actually support a particular architecture.
Absolutely, that's on the roadmap. So right now, in this current version, you won't find anything that like solves that problem for you magically, but the model runner is going to have multiple backend variants to support different hardware, and the models themselves. Like right now, the spec is just talking about a single model, but we're interested in working on a manifest list model index version of this that creates a concept that's analogous to a multi-arch image, but adds the information that you need beyond what's in the current platform section of the manifest to make decisions specific to an LLM context.
Thank you.
I have a question. So how does this fit with the Olama thing that they have where they pull images and I guess they run on locally on your laptop? So what are the differences? And also some of the work that is going on with standardizing models in OCI format, right? So I see that you have models here in GUIF format, but will there be support for models in OCI format, or when that's standardized, or what? I mean, what's your take on that?
So this is an OCI artifact. Like this specification is OCI compliant. So it's using, let me open the other file here. Hold on. So this is an OCI image manifest, but we're not using the image config type. We're defining our own config type. So that's sort of creating an OCI artifact in a way that meets the artifact guidance in the OCI image specification. So this is a packaging as an OCI artifact. What makes it different than the other flavor of this that I have seen is that the layers themselves are not creating a file system. So there's no rootfs that's being created by the sum of these layers. Instead, we're just storing them alongside information about their type, like what their purpose is, so that the runner can, identify individual files like a GGUF file and then memory map it in order to run it. So it's an OCI artifact, but it's not a container image. And it is very similar to some of the stuff Olama is doing under the hood. And I think of the people we would like to work with to standardize, they're definitely near the top of the list.
Are you working with the ORAS folks, the people who've been trying to standardize OCI artifacts and registries?
I've not met with them yet. I've seen their stuff. I would like to work with them.
And so you envision these individual files to be just downloaded onto the local machine or pushed directly into the GPU, or how do you envision pulling one of these mechanically?
So in like the first version of our integration, there's a daemon that is, you could think of it as something similar to Containerd, but for running models, and it pulls these models and stores them on disk. And then it handles like running them when it receives requests via the OpenAI API.
Yeah. Yeah, I mean, I've been working with some major financials and DoD folks on stuff like this. But I'm biased because I'm with a company that has a distributed file system. They want to use the OCI registry, but not actually read the content from the registry, but read the content from a distributed file system. So they're using the registry basically as for provenance and other metadata, but not actually to house the content.
That's interesting. I need to learn more about that.
Emily,
Yes.
what do you think could be the next steps here? Is there something we could do to help? Do you guys have like a meeting to like get community people to come give you feedback, or what do you think?
I think scheduling something like that would be helpful. Part of the reason I'm here is for advice in exactly that department. It's like if you know of other folks that are working this that I might not be aware of, what some of the ways you think are best to reach out to projects that are working in a similar space. We're open to basically everything.
Will you let us know when this is as you're saying open sourced, and then we could we can share.
Yeah.
Okay.
The spec is open right now. It's still very much in progress, but it's open, and the distribution tool will be open later today or this weekend.
So Emily, I'd like to see a quick start or something on this. Just a really easy like that. That's a way that things pick up steam. If it's if there's an easy way for people to get their hands dirty with this, then I think that will help with advocacy and feedback, in my opinion.
Hopefully some of that will be coming, although I mean, some of that will definitely be coming through the lens of like a quick start with the Docker model runner, which will be available very soon. But I'm trying to work on a version of this that's only using the open source components because I don't want this to be a pitch for the product. I want this to be a pitch for
Got it.
the concept.
That makes sense.
I know the folks at Red Hat, well, Podman, Podman, the open source Podman, is doing something very, 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 very similar. I saw a demo of it. I don't know if it was a public demo. Are you coordinating with them so that the standards become standards versus specifications, and that it would be the same way to do what you're trying to do under Model Runner as what the Podman folk are trying to do, or is there going to be a bifurcation here?
My understanding was that they were still packaging the artifacts as container images at the end of the day. So we've made some slightly
No,
different decisions
that's
than
not
they
true.
have.
That's
not true?
incorrect.
Okay.
That's incorrect. They're doing similar to you. It's a single file.
This is all on our end. We're not yet talked to them. That's gonna be the answer for most of these people because we did not get permission to sort of open this up, what we've been working on, until yesterday was the day I pushed this and made it public in Docker. So now that we can sort of share what we've been working on, we'll be able to have more productive conversations with the Red Hat folks, I think.
I think I spoke with them recently. I think Brent Bauer, is it? God, I'm putting out on who it is.
This is not, is the Ramalama stuff you're talking about?
No. This is the Brent Bod. Brent. His first name Brent. That last name is Baude. I think he's the guy you might want to reach out in the Podman side.
Thank you. I appreciate that. Any other
And
questions?
he would be a link to the other people in the Podman cabal.
Thank you.
Emily, thank you very much for doing this. We
Thank you.
appreciate being on the bleeding edge.
Thank you for listening to my not very polished pitch, but we want to get out there early.
Oh, hey, no, it's this is great. It's to the point. Doesn't have to be crazy, right? It's I'm actually leaving understanding it versus being confused by it. So that's a great thing. Thank you, Josh. Thank you, Deep. Actually, everybody, we have to do this round of applause for Deep. This was not very easy getting this paper to this point. So Deep, thank you very, very much. All right, so we'll it's an hour, so we'll officially end it now. It's 9:02 on March 28th. Thank you, everybody. If you want to stick around and chat, please do. If otherwise, we'll officially end it here. And safe travels to KubeCon, everybody.
Thank you so
Thanks,
much.
Ron. Thanks, team. Take care.
All
Hey,
right.
Ron. How'd your event go, by the way?
What's that?
Your event a few months back, how'd it go?
Oh, the AI day went well. The only thing was the weather. We had it was a torrential downpour
Oh, no.
the whole
thank
day.
you. Bye.
Bye, Mustafa. Careful driving.
Couldn't
We only do Waymo
have
here
been
in the
worse
AI
than the
group.
snow on the first day of KubeCon.
What's that?
I think it was KubeCon that the first day had incredible slushy snow.
Oh man, that's rough.
I think that was KubeCon. One conference I went to recently, it was horrid. Well, things good for you otherwise?
Yeah, it's slow and steady, but all good. How about
Excellent.
you?
Good. I'm finally wrapping up this project that's been ending for, the last 2%.
We're still recording, FYI, just so you know.
Okay. The project that I told you about that I will not tell about on the recording. It's on its last legs of wrapping up. We're now waiting for contract stuff before the unnamed financial does stuff with it. So we'll see. But my time, the good news is now that it's done, is my time totally opens up. Unless they find problems with it. I'm done.
All right. Well, we'll try to find something interesting then for you to do.
We'll talk out of band. All right. Thanks again for organizing this. I hope my 2 cents was useful.
Nope, it's on point.
Yeah.
So very good.
Yeah.
Right.
The problem, I go to the age-old problem of what's the difference between a spec and a standard.
Yeah. Only time will tell. Yes.
Exactly. We have a new standard. I'm like, no, you don't. You have a new specification.
Yeah. Well, at least they're working on it. All these groups, and so that's
no. It's good things.
thing.
It's just, there's the specification battles always.
Yeah. Gotcha.
All right. You got
Well, have a
stuff to
good
do.
weekend.
So do I. You all have a great weekend. Bye.
Bye.